Ever wonder how we feed the entire planet? Like, seriously, billions of people and all needing food, it's mind-boggling. It's a question that had scientists back in the 1800s, well, freaking out a little bit, to be honest.
Yeah, they were staring down what they thought was the collapse of civilization, no less.
No pressure or anything, right?
It sounds dramatic, but they weren't exaggerating, really. The world depended on chili and saltpeter back then, basically, a natural nitrogen fertilizer.
Okay, so like fertilizer from a mine.
Exactly. But here's the catch: is running out fast.
Oh, that's not good.
Thanks.
For anyone who skipped their botany class, why is nitrogen so essential? I mean, besides making things go boom.
Right. Well, it all boils down to how plants work. Nitrogen's a core component of chlorophyll, the pigment that makes leaves green.
Photosynthesis and all that.
Precisely. Without nitrogen, plants can't make enough chlorophyll, their growth gets stunted, harvests shrink, and suddenly feeding a booming population becomes a lot harder.
So we've got a dwindling supply of essential fertilizer. What were the options back then? Did they even have any?
It was a tough choice, honestly. Use the saltpeter to grow food, or, well, blow things up.
Always a classic dilemma.
And the crazy part is, about 80% of that precious saltpeter was going straight to agriculture. Only a tiny fraction for explosives, which tells you just how vital food security was.
So finding a new way to get nitrogen into the soil was non-negotiable.
Absolutely. It wasn't a want, it was a need.
You sent over some seriously cool lectures on the history of, like, chemistry and technology related to all this. And let me tell you, our view of the Haber-Bosch process is about to get flipped on its head.
Yeah, most people hear that Haber-Bosch saved the world from starvation and that's it. End of story. But it wasn't the only solution being explored, not by a long shot. These lectures highlight all these other scientists and forgotten inventions that get left out of the textbooks. It's a much bigger story.
Okay, spill it. Who are these unsung heroes of nitrogen?
Way before Haber and Bosch, you had chemists trying all sorts of crazy ideas to pull nitrogen from thin air.
Sounds ambitious.
Oh, it was. Take the lithium reaction from the 1860s. Beautiful chemistry, really elegant, but trying to recycle the lithium, total nightmare, logistically speaking.
Points for trying, I guess.
Yeah.
But yeah, not exactly scalable.
You got it. Then there's this barium hydroxide cycle. Super clever, actually. It used temperature differences to drive the reactions.
So like an early attempt at a sustainable closed-loop system.
Exactly. Ahead of their time, but not quite there yet.
Okay, you're saying all this like you've got something even better up your sleeve.
Oh, this next one is a wild ride. Electric arc furnaces, a total accident of a discovery, and a compound more versatile than, I don't know, a Swiss Army knife.
You've officially piqued my interest. Hit me with it.
Calcium cyanamide, that's the key.
Wait, isn't that?
Yes, the stuff they make metformin from, for diabetes. But before it was regulating blood sugar, it was going to be the future of fertilizer. And how they made it. Total mad scientist stuff involving electric arc furnaces.
Hold on, electric arcs, like Frankenstein-style lightning bolts. How does that make fertilizer? Okay, I'm all in, you've convinced me. How do you make fertilizer with something straight out of a Frankenstein movie?
Picture this, a massive container, right? Like a cauldron, but instead of fire heating it up, it's this huge electric arc, like a controlled bolt of lightning zapping between these electrodes.
Intense. But did it actually work?
Oh, yeah. It all started with, let me think, Henri Moissan. He was playing around with these electric arc furnaces and stumbled across calcium carbide.
Okay, and calcium carbide is
Help me out here.
the magic ingredient. Turns out you react that carbide with nitrogen and bam, you've got calcium cyanamide ready to feed those crops and give chili and saltpeter a run for its money.
So maybe less Frankenstein, more like early 20th century industrial wizardry.
Pretty much. And the impact was huge. This wasn't some small-time operation. This was big industry, companies like American Cyanamid cranking out tons of this calcium cyanamide fertilizer right up until the 1940s. The 1940s. Wow, this wasn't just a blip on the radar then. Why'd they stop using it if it was working so well?
Well, a few reasons, really. Those electric arc furnaces. Massive energy hogs, especially compared to what came later. Plus, calcium cyanamide, while good at its job, wasn't the simplest fertilizer to handle. Sometimes it would release ammonia.
Which, good for plants, but in high doses.
Yeah, not so much for people.
So, not perfect, but still pretty ingenious for its time.
Yeah.
And a crucial part of this nitrogen story.
Absolutely. It shows you how innovation works, like waves, each technology having its moment. And get this, those electric arc furnaces weren't just for fertilizer. They played a big role in something completely different. Gold mining.
You're kidding, right? Fertilizer and gold. How are those two even remotely related?
Cyanide.
Wait, cyanide. As in The poison.
The one and only. But here's the thing. In the right setting, controlled and diluted, cyanide is awesome at getting gold out of ore.
Okay, I did not see that coming.
And how do you make cyanide? You guessed it. Calcium cyanamide often played a part.
This is blowing my mind. This one compound is connected to feeding people, treating diabetes, and digging up gold. That's one overachieving chemical.
And it just goes to show, scientific discovery is rarely a straight line. It's those unexpected connections that often lead to the biggest breakthroughs.
Okay, so with all this talk of alternative methods, where do Haber and Bosch fit into this whole saga? They're the ones who supposedly cracked the code, right?
Right, but funny enough, even Haber wasn't focused on ammonia at first. BASF, the chemical giant they brought him into, get this, improved their electric arc nitrogen setup.
Seriously. The company that becomes famous for the Haber-Bosch process was first invested in electric arcs.
It's true, but Haber, always the big thinker, he had other ideas. He was obsessed with making ammonia directly, no natural sources needed.
Which, as we've established, was like the holy grail of chemistry back then.
Totally, but everyone thought it was impossible. There had been attempts, some using iron as a catalyst, but nothing panned out.
So what made Haber think he could crack it?
He had this hunch, based on how he understood chemical reactions working, that high pressure was the key. No one had really explored that before.
So he was going against the grain, like a true maverick of chemistry.
And this is where he really shines. To test his idea, he builds his own high-pressure equipment, practically unheard of back then. This thing let him try out pressures and temperatures no one else could. And that's when he finds it. Osmium, the magic ingredient. Well, as a catalyst anyway.
Osmium, the super dense element.
That's the one.
Okay.
And it was the missing piece of the puzzle. With osmium, Haber could finally make ammonia at decent temperatures, although still crazy high pressure.
So he did it. Ammonia from thin air, case closed. And then Bosch swoops in to take all the credit.
Not so fast. See, figuring out the chemistry in the lab is one thing, but turning that into a factory process, whole other ballgame. That's where Bosch's engineering brilliance comes in. And honestly, even he was skeptical at first. He saw right away that what worked for Haber in the lab wasn't going to cut it on an industrial scale.
What were the biggest problems? Besides osmium being, well, osmium. Rare and expensive and all that.
For starters, yeah, the osmium. They even considered uranium for a hot minute uranium. But too unpredictable for something this big.
Slightly terrifying, but I get it.
Right. So they went back to iron, the catalyst from those earlier attempts, hoping to figure out a way to make it work.
Back to the drawing board. What other hurdles did they have to overcome?
Well, Haber's setup used super pure lab-grade gases. Not exactly practical when you need to make tons and tons of ammonia. Bosch and his team needed a cheap, readily available source of hydrogen, and fast.
Mass production needs. Mass ingredients. What'd they do? Go on a global hydrogen hunt?
They got even more creative than that. They invented a solution. Steam reforming.
Wait a minute. Steam reforming. That rings a bell.
It should. It's everywhere these days in all sorts of industrial processes. Kind of a perfect example of how fixing one problem can snowball into something way bigger, you know?
Okay, I'm hooked. Give me the steam reforming crash course.
Yeah.
How'd they make it work?
So, you take hydrocarbons, something like methane from natural gas, plentiful even back then, and you react it with superheated steam.
Sounds intense.
It is. It's like a high-pressure chemical breakdown, splitting those hydrocarbons apart and releasing hydrogen gas, all ready to go for making ammonia.
So they basically created a hydrogen factory using fairly basic ingredients. That's pretty clever.
Exactly. And this wasn't just a quick fix for them. Steam reforming changed everything, became the foundation for making tons of stuff we still use today. But back to Haber and Bosch. Even with the catalyst and the hydrogen figured out, there was still one massive problem for Bosch to solve.
Turning this whole thing from a lab experiment into a real factory process, right? Can't be easy scaling something like this up.
Right. Haber's apparatus, ingenious as it was, wasn't built for industrial scale production. Bosch had to rethink the whole thing, consider how materials behave under those extreme conditions, figure out how to make it safe, no explosions, all while making sure it's efficient and affordable.
Like going from building a fancy watch to a whole locomotive.
Mm.
Both impressive, but totally different scales of engineering.
Perfect way to put it. Building a locomotive takes special skills, and so did this. Bosch had to use his knowledge of metals, engineering, and chemistry all together to make a system that could handle those insane pressures and temperatures.
So it's really about collaboration in the end. Haber's chemistry genius plus Bosch's engineering genius.
Exactly. It's a good reminder that scientific breakthroughs, they don't usually happen in a vacuum. It takes different minds, different skills, working together to turn an idea into something that can change the world.
And wow, did this one ever change things? I mean, think about it.
Yeah.
Agriculture, explosives, even the nylon in our clothes. None of it's possible without what Haber and Bosch did.
Right, but those lectures you sent over, they had a really interesting perspective. The professor actually argued that even though Haber-Bosch has defined the last century, we shouldn't be afraid to look back at older tech, like that electric arc process, especially now with all the advancements in renewable energy.
It's easy to get stuck in the "this is how we've always done it" mindset,
Mhm.
but clean energy changes the game, right?
Hmm.
Maybe those older ideas aren't so outdated after all.
Exactly. Imagine powering those electric arc furnaces with solar, wind, maybe even fusion someday. Suddenly, the energy cost isn't such a big deal anymore. Plus, making nitric acid directly that way could open up all sorts of possibilities for different industries.
It just goes to show that scientific progress isn't always a straight line. It's messy, full of detours, and sometimes old ideas become new again when we make new discoveries.
Absolutely.
So where does that leave us? What's the future of nitrogen fixation? Anyone's guess, really, but it makes you wonder.
It really does. And it reminds me of that strange connection we talked about earlier, the iron and molybdenum in the Haber-Bosch catalyst. Those same elements are what nature uses in the nitrogenase enzyme.
It's almost too perfect to be a coincidence.
Right. Makes you wonder if there's something deeper going on that we're just not seeing yet, some fundamental link between how we do it and how nature does it.
Like nature's leaving us clues for a more elegant solution, if we could just figure out how to read them.
Wouldn't that be something? To unlock the secrets of natural nitrogen fixation, use it in a way that's efficient and sustainable. Amazing to think about.
This whole deep dive into nitrogen has been quite the ride. Forgotten inventors, mind-blowing coincidences, and more twists and turns than I was expecting.
It really shows you the power of human curiosity, that desire to understand how things work, to make them better. And it reminds us that there's always more to learn.
That's the beauty of it, right? Every answer leads to more questions. Until next time, keep exploring, keep asking questions. Who knows what amazing discoveries are out there waiting to be found?